Pause the film now to do the question before me. So I've got an isosceles triangle, and I know that its area is 12. I need to work out the perimeter of the triangle, so I'm going to need to work out x. Right, I know that the area is 12, so I know that 5 times h over 2 is 12, which tells me that 5h is equal to 24, so h is equal to 24 divided by 5, 4.8. Right, now let's have a look at 1/2 of this triangle. It looks like that. That's the height, that's a right angle, that's 2.5, and that is x. Well, that's going to enable me to find x using Pythagoras. X squared will equal h squared, well h is 4.8, so that's 4.8 squared, plus 2.5 squared. So that tells me that x squared is 29.29 and so on. And if I square root that, then x is equal to 5.41. Okay, now I need the perimeter of the triangle. So what I'm going to have for the perimeter is I'm going to have 5.41 plus another 5.41 plus 5. So the perimeter of my triangle is 15.82, and I'm asked to give that correct to 3 significant figures. So the answer is 15.8 centimetres to 3 significant figures. Pause the film now to do the question before me. Now I need to find the area of this shape. So I'm going to need to know the length of AC because that's the diameter of that semicircle. So I'm going to use Pythagoras to find the length of AC because D is the hypotenuse. So I've got D squared equals 6 squared plus 6 squared, which means that D squared is 72, and so D is the square root of 72. Let's leave that as it is for the moment. Right, so now I need to work out the area of the shape. I'm going to start by working out the area of this semicircle. The area of a circle is pi r squared, so the area of a semicircle is pi r squared divided by 2. And I know that D, the diameter, is the square root of 72, which means that r must be the square root of 72 over 2. So for my area of the semicircle, I'm going to have pi times the square root of 72 squared. So that's the square root of 72 times the square root of 72. And all of that I'm going to need to divide by 2 because it's a semicircle. Now, of course, you could just put that into your calculator. I'm not going to do that. I've got pi times root 72 times root 72 is 72. 2 times 2 is 4. And I'm going to halve that. So that gives me 18 pi divided by 2, which boils down to 9 pi. And that's what you'd have got if you'd have put the original expression into your calculator. So that's the area of the semicircle. I'm also going to need to know the area of that right-angled triangle, this one here, which I'm going to write a big D in the middle of. Now that is base times height divided by 2. So it has an area of 18. So the area of the whole shape is going to be 9 pi for the semicircle plus 18 for the triangle. And all you need to do now is to stick that into your calculator and give your answer to 1 decimal place. And that should give you the answer of 46.2 square centimetres to 1 decimal place. Pause the film now to do the question before me. Right, I need to work out the perimeter of the shaded shape. So I can already see that A to D is 17 and D to C is 15. So I really only need to find the curved length, which happens to be a semicircle. So that happens to be half a circumference. So I need to find what AC is because AC is the diameter of that semicircle. So I can find the diameter by doing Pythagoras. D squared will be 17 squared minus 15 squared, as D is not the hypotenuse. So that means that D squared is 64, and so D is 8. So now I can write an expression for the perimeter of the whole shape. The perimeter of the whole shape will be half the circumference, pi d times 8, plus 17 plus 15. And of course, I know that the diameter is 8. So it's going to be pi times 8 over 2 plus 17 plus 15. Put that into your calculator and you'll get the answer 44.566 and so on. And I'm asked to give the answer to 3 significant figures, so that's going to be 44.6. And there is the perimeter of that shape. Pause the film now to do the question before me. Now I need to work out the total of the shaded regions. So what I'm going to do is I'm going to work out the area of the circle, which will be pi r squared, and from that I'm going to subtract the area of that right-angled triangle. And that'll leave me with the shaded areas. So how to work out the area of the circle? I need to know the radius. Now looking at this, I could find the diameter using Pythagoras. So I'm going to do that now. Diameter squared equals 8 squared plus 15 squared. So the diameter squared is 289. So the diameter is the square root of 289, which is 17. So the diameter is 17, so the radius is 8.5. Brilliant. Now I can write an expression for the area of the circle. And from that I can subtract the area of the right-angled triangle. And that would leave me with the shaded areas, wouldn't it? So if I put that into my calculator, I get the answer 166.98 and so on. And if I put that to 3 significant figures, I get the answer 167 cubic centimetres to 3 significant figures. That's the end of the film. If you found this useful, please press like, and then YouTube will know that you appreciated this content, and so will I. If you have got any questions, please leave a question in the comments and I will respond. I hope you found the film useful. See you next time. If you're finding this film useful, please tell me so by hitting like.